So, right now we're going to cover the laws of thermodynamics. The zeroth law is that two objects in equilibrium with a third are in equilibrium with each other.
The first is that the change in internal energy is equal to the heat plus the work.
The second being entropy is always increasing, which is the law that air conditioners use.
And the third is that as the temperature approaches zero, the entropy also approaches zero, which is known as absolute zero. With the second law, entropy always increases because heat flows from hot to cold, but in air conditioning, air is actually flowing from cold to hot. So essentially it's going against the second law, but since the overall entropy of the surroundings is increasing, it makes up for that entropy loss, and it does in the end increase.
When you turn on your air conditioner, a few things happen. First, room temperature air is sucked into the compressor, which is converted into a high temperature, high pressure gas, and that goes from H1 to H2. And most of that high temperature, high pressure gas goes into the condenser, but some is released back into your room as more heat.
So once it's in the condenser, it becomes a liquid, and that leaves with a new enthalpy of H3 and enters the evaporator, where it undergoes free expansion to turn it back into a gas, and some of it is released as cold air back into the room, and the rest is returned back into the compressor with an enthalpy of H4.
And if you were to have a window unit, then your window would be sitting right here, and this would all be happening inside it. This is how heat moves. 1, conduction, 2, convection, or 3, radiation. Conduction occurs when two objects are touching and heat is transferred directly from one object to another.
Convection occurs when there's movement of a fluid to transfer the heat from one object to another.
And radiation occurs when heat transfers directly from a source of an object to whatever is being heated, so like the sun melting ice, and it just goes through space.
These are the equations that pertain to air conditioning to relate it to thermodynamics. The first one is the cooling capacity, which is equal to the density of air times the CFM times the change in enthalpy, and CFM stands for the velocity of airflow. The next one is COP, which is coefficient of performance, and that's equal to the cooling effect, which is the enthalpy of the air entering minus the enthalpy of the freon re-entering the compressor, divided by the work input, which is equal to the compressor work minus the evaporator work. And then these are the equations for the change in enthalpy and the change in entropy. The change in enthalpy is the heat capacity times the change in temperature plus the quantity of 1 minus beta times temperature times the volume times the change in pressure. And the change in entropy is equal to the heat capacity times the change in temperature divided by the temperature minus beta times volume times the change in pressure. And in both cases, the beta used is equal to 1 divided by the volume times the partial derivative of the volume with respect to the temperature at constant pressure.
This is the history of air conditioning.
In 1758, at Cambridge University, Ben Franklin and John Hadley found that volatile liquids evaporated faster than water, which meant they could freeze water.
In 1820, in England, Michael Faraday makes the same discovery by liquefying ammonia, and this is an ammonia molecule.
In 1851, in the U.S., Dr. Gorey built an ice machine that compressed water to form ice. Air was blown over the ice to keep it frozen. It was patented with the plan to cool buildings all over the world, but since he had no financial backing, it was unsuccessful.
In 1881, in the U.S., President Garfield was shot on July 2nd. Naval engineers on the ship he was on built a cooling unit to keep him comfortable, and they used water-soaked cloth with fans blowing hot air overhead.
In 1902, in Brooklyn, New York, Willis Carrier invented a device to treat air for the Sackett-Wilhelms Lithography and Publishing Company. This was done by blowing air over coils to control room temperature and humidity in order to keep the ink aligned and the paper from wrinkling. This later became the Carrier Air Conditioning Company of America. And this is a picture of the AC unit that they used.
In 1906 in North Carolina, Stuart Kramer, a textile mill engineer, creates the first device to add water vapor to air. It made yarn easier to spin and less likely to break. And he was the first person to use the phrase air conditioner.
In 1914 in Minneapolis, Charles Gates Mansion had an in-home AC unit. Unlike today's, this one was 7 feet high, 6 feet wide, and 20 feet long, but he died before the house was completed, so he never actually used the AC unit. And then this is one of the ads that they used back in that time in order to encourage people to get air conditioning for their homes.
In 1931 in the US, Schultz and Sherman made air conditioning units for individual home rooms. It was the first time they used window ledges for the air conditioning unit, and it was only bought by the wealthy. It cost anywhere from 10 to 50K. And this is an ad trying to get people to tinkle on the air conditioner and how they can be cool, and it shows somebody in the corner installing it. Like, oh, it's so easy, you can do it yourself.
In 1939 in the US, Packard made the first car that had air conditioning. It was manufactured by Bishop and Babcock. The controls were under the hood though, so it had to be stopped and the hood had to be opened and the compression had to be disconnected in order to turn it on and off. And it cost $279, and it also required a second factory since the same factory who manufactured the car couldn't do that as well. And it took up a lot of space, including half of the trunk. So since there was really no way to moderate the air and it was so large and obstructive, it was discontinued in 1942. And then this is a picture of the car.
In 1942, in the US, the first summer peaking power plant for growing electrical load was created, and they generated power using air conditioning alone, essentially. And what they did was they insulated all their piping so it kept all the air and kept everything inside the pipes cooler, and it was just better for the company.
In 1947 in Britain, the writer Markham wrote, "The greatest contribution to civilization in this century may well be air conditioning, and America leads the way."
In 1953, in the US, it's post-World War II, and there's a huge economic boom. And residential air conditioning becomes really common. More than 1 million units are sold in just this year, and this is just a woman who looks very happy in her long-sleeve dress to be having an air conditioner.
In the 1970s, also in the US, window units became less popular and central air grew popularity. And this uses condenser coils and a fan to pull air in, pass it over the coils, and then blast it out through the vents. And this used Freon 12 refrigerant. And then this is just an ad showing the first thermostat that was used in the central air conditioning units.
In 1994, Honeywell and Carrier, who are both people, developed a more environmentally friendly coolant. And so a little bit about Carrier. In 1901, he graduated from Cornell University with an engineering degree. And then 84 years later, he was inducted into the National Inventors Hall of Fame. And not long after that, he was one of Time Magazine's 100 most influential people of the 20th century. His contributions to air conditioning, including early installation in Asia and Europe, indicated a universal application for them, and he continued to lead the industry with energy-efficient products and manufacturing processes. The first AC made was a roller towel wrapped in burlap that was saturated with calcium and chloride brine. It added heat, salt, and odor to the air, but it didn't successfully remove humidity. And this is just a blueprint of the first air conditioning unit that he made.
And then in 1996, Freon was linked to ozone depletion, so it was banned in most countries, and most of them started to switch to R134A, which is another refrigerant that's more environmentally friendly. And then this is just an ad saying, that was when they started using Freon for the condensing units. We know that's a lot of information, so now we're going to explain it in a fun way. People, There's no need to be hot because of thermodynamics. Here's how the idea started back in 1758. Then Franklin and Hadley were at Cambridge, freezing H2O by evaporating alcohol, but it was volatile. It's the creation of HVAC. It's the creation of HVAC. There's no need to be hot and no need to sweat. Just buy an AC, don't fret. It's the creation of HVAC. It's the creation of HVAC. Pour your compressed water in an ice machine and blue air to keep it frozen. Fast forward to 1881. President Garfield was shot by a gun, so naval engineers tried to create a unit to keep him cool. Carrier came with the breakthrough to keep paper flat. In 1902, then this formed the first window unit, and homes were cooled in '04. They coined the term HVAC. They coined the term HVAC by an engineer named Stuart Kramer to prevent the breaking of yarn. They kept improving the HVAC. They kept improving the HVAC. Installed in Gates' mansion, then came CFCs, which was later federally banned. Schultz and Sherman made a smaller unit to sit on a ledge, which cost nearly $10K. Then Packard made the first AC car. Later, in 1942, the first power plant was made for electric loads. Then AC boomed after the war in the 1950s. They had success with the HVAC. They had success with the HVAC. Central Air came along, running free on 12, but so did the Title IV Act. HVAC, time to improve the HVAC. Freon caused ozone to deplete, so they made the switch to R134. HVAC, linking Thermo to HVAC. Honeywell and Carrier developed more coolants, but that didn't harm the air. HVAC. I never missed a class. Given heat, find the mass. People say this is tough, but we can't get enough. Apply it to the world. My brain just did a twirl. Heat work and entropy. Let's apply this to AC. There are 4 laws of thermodynamics that we all should know. These relate to air conditioning, 'cause the sun is gonna heat. And thermo is so neat. So we'll sing this beat. About AC. Freon sucks air in, and dumps it where it's been. Undergoing expansion. It goes cool air. Now let us be the teachers. AC has 3 key features: evaporator and condenser. Then the compressor. Heat flows from hot to cold, but not in AC. Behold, it doesn't break the law. H system goes up. Temperature versus heat. where do these two meet? Heat is flow of energy. Temp is internal kinetic energy. Heat moves in three ways, going through a different phase. We're just gonna praise. Carrier. Air is gonna flow, but it costs a lot of dough. It becomes a status quo. So have AC. Cooling off. I'm cooling off. I'm cooling off. I'm cooling off. Hey, two objects in equilibrium with a third are in equilibrium with each other. And internal energy is the heat work. Entropy always increases, and temperature is related to entropy. These are the laws of thermodynamics, and heat moves by conduction, convection, radiation. Cause the heat melts ice in tons, and sweating is so done. Thermo is so fun. Applying laws. From the HVAC industry, tree. Inventors jump with glee. Soon baby will see. How great it is. It's so great. No longer sweat. Use AC. Cooling off.